In this video, we're going to be looking at linear inequalities. And the solution of an inequality is the set of all real numbers x that makes the inequality true. So let's look at an example. If we have 5x plus 9 is greater than or equal to x plus 20, and we want to find the set of values for x for which this is true, okay? So the first thing that we really want to do is to get the terms on the relevant side. So we want to collect our x's and collect our numerical values. So we can take x from both sides, which will give us 4x plus 9 is greater than or equal to 20. And then we can take 9 from both sides. We can minus 9 here, and we can minus 9 there. And so that will get rid of this, and that will give us 4x is greater than or equal to 11. Okay? And then all we need to do is to get x by itself. So it's like as if this was an equal sign effectively. And so we can divide both sides by 4. So divide that by 4 and divide that by 4. And then this will give us an answer of x greater than or equal to 2.75. Okay, and then that is our answer. So that is the values of x for which 5x plus 9 is greater than or equal to x plus 20. Okay, let's look at a second example. How about we want to find the set of values for x for which 12 minus 3x is less than 27. Okay, so I'd pause the video now and give it a go yourself, and once you're ready, continue watching. So the first thing we're going to do is subtract 12 from both sides. We're going to subtract 12 from this side, we're going to subtract 12 from this side, and then that will give us, so if we subtract 12, it's going to give us negative 3x is less than 15, okay? And again, what we want to do this time is to divide both sides by negative 3. So if we're going to divide both sides by negative 3, we're going to have to turn around the inequality sign. Okay, so if I was going to go by negative 3 and divide that by negative 3, effectively what we're going to be doing is going to be putting in x, so minus 3 divided by minus 3 is x, switch around the inequality sign. So if you're dividing it by the negative number, we're going to switch it around, and we're going to have minus 5 over here. So effectively our answer is x is greater than negative 5. And as a final example for these more simple linear inequalities, let's look at the following. So we have 3 open bracket x minus 5 on the one side, and we're going to say that is greater than 5 minus 2 open brackets x minus 8. Okay, so the first thing that we want to do is to expand our bracket. So let's rewrite this in full. So 3 times x is 3x, minus 5 times 3 is negative 15, and that's greater than 5 minus 2 times x is negative 2x, minus 2 times negative 8, well, we've got two negatives, makes a positive, so that gives us positive 16. Okay, and as before, we want to collect our like terms, so we're going to add 2x to both sides, so that will cancel that out and put it over here, so it's going to give us 5x, and we're going to add 15 to both sides, so that's going to cancel that out, so it's going to be 5 plus 16 plus 15, which is going to give us 36. And so again, at this point, we're going to divide both sides by 5 as such, and that will then give us our answer of x, because 5 divided by 5 is 1, and then 36 divided by 5 is x is greater than, don't forget to put it the same symbol, obviously, is greater than 7.2. And that gives us our answer. Now, You may sometimes need to find the set of values for which two inequalities are true together, and number lines can be useful to find this solution. Okay, so let's have a look at some number lines to see how we can use them to solve our answers. So let's say we have something like x is greater than -2 and x is less than or equal to 4. Okay, so how would we do this? Now, excuse my lack of straight line here, but I'm going to try and draw a line across the screen like such, and we're going to then sort of put some numbers on it. So this is going to be our number line. Oh, -2, 0, 2, 4, 6. Okay, so we've got from -6 to 6 on our number line here. And we're going to approach these one by one. So the first one we're going to look at is x is greater than -2. Okay, now when we have a greater than symbol, which means that the number here isn't included, we can represent that with a little empty circle on our screen. And when we have something which is greater than or equal to or less than or equal to, then we can fill it in like such. So greater than or less than, we'll just have a circle. Greater than or equal to and equal to or less than and equal to will be filled in with a circle like this. So if we've got x is greater than -2, we're going to represent that with an empty circle like such. And then because everything that's greater than that, we can simply draw an arrow being like it's everything from here forward, but obviously it doesn't include this because this represents that it's not equal to -2. And then we can then do the same thing with our x is less than 4, but this time it is less than or equal to 4, so we can put a little filled in circle here, and we do the same. We just do an arrow going that way because it's forever going negative. X is less than or equal to 4. And at this point we need to find out what is the numbers that can fit both of these expressions. Okay, so what are the values that satisfy both equalities simultaneously? And the answer would be wherever they are essentially overlapping. Now, obviously it can't include this number here because this is what we said before, it doesn't include -2. So we'll represent that with a circle again, and it's all this information and all these numbers in between here up to and including the 4, as we said before, because obviously this first one includes 4, this one includes 4 because it's a equal to sign, and therefore so does our inequality simultaneously. So let's look at an example where we want to find the set of values of x for which, let's say, x minus 5 is greater than 1 minus x. So that's our first one. Or, so we're going to put or here, or 15 minus 3x is greater than 5 plus 2x. Okay, so it looks like there's quite a lot of information on here, but let's give it a go. Okay, so in the previous example we looked at the situations where this and this would be satisfied because we had, let's say, a line that looked like this and we have a line that looked like this, and so we could say that this region here, was the bit that satisfied both this and this was satisfied by this line here. Okay, but in this situation we're looking at where this inequality or this inequality is satisfied. Okay, so the first thing we're going to do is look at our x minus 5 is greater than 1 minus x. Okay, now as before we're going to add x to both sides, so we've got 2x minus 5 is greater than 1 because we're adding x to this side, which makes that 2x, and that gets rid of the other x. And then we're going to add 5 to the right hand side. We'll add 5 to both sides. That's going to give us 2x is greater than 6, which means that x is greater than 3, because if we divide both sides by 2, that gives us x is greater than 3. Okay, so that's the first part. And now we're going to solve this inequality. So again, same principles apply. very easily, we're going to collect our relevant terms. So let's take 5 from both sides to begin with. So 5 minus 5 is 0, 15 minus 5 is 10, minus 3x is greater than 2x. And then we're going to add 3x to both sides, so that gives us 10 is greater than 5x. And then we're going to divide both sides by 5. So 10 divided by 5 is 2, and 5 divided by 5 is 1. So that's going to give us x. And we can just say that that is x is less than 2. So just turn that around essentially. Okay, so at this point we need to wonder, how are we going to solve this on our line? So let's just draw out our number line so that we can represent this. So let's draw a number line across here, like such. And we're going to put out some values that encompass this range. Got minus 4, minus 2, 0, 2, 4, 6, and so on. So here's our number line now, and we want to figure out what is encompassed within this region. So let's start with the x is greater than 3. Now we know that if it's going to be greater than 3, but not greater than or equal than 3, then we're going to have to represent this with an empty circle because it doesn't include 3 itself. So let's put that on our line. So we've got 3's around here, like such, and it's greater than 3. So it goes all the way over to here. And then our other term is x is less than 2. And again, it's not equal to, so we're going to represent that with an empty circle. And we're going to find 2 on here, put an empty circle underneath it, and as it's less than 2, we're going to put an arrow going this way. Okay, and so at this point we need to figure out what is our answer. Now before, we were looking for where it overlaps, but here, if the question had been x and, so this inequality and this inequality, there would be no solutions because there are no overlaps. But as the question asks for this or this, our solutions are simply x is greater than 3 or x is less than 2. And this can be written in set notation. I don't know whether or not you would know this yet, but I will create videos on set notation later, and we can simply write, I'm not very good at drawing these curly brackets, but x is less than 2. So this will represent obviously our first situation, union with x x is greater than 3. That's like such. And that would be how we could represent the same answer in set notation. If you have any questions about this video, please leave a comment below and I'll get straight back to you. And make sure you subscribe to my channel because I'll be producing new maths videos every single day. Thank you very much for watching.